Now let's take a look at another way of approaching this displacement for our position vector. So if we want to find the change in R, we recognize the fact that the change in R for our position vector is equal to the final minus the original position, like so. And it makes sense. All right, last year though, when we started to talk about positioning of vectors, notice how I placed R1 and R2. Hey, when we're adding vectors, we make sure that we place them head to tail, Statue of Liberty style. But when we're actually subtracting, another way of doing it, instead of last year's method where we would add the opposite, when you subtract, instead of placing them head to tail, you place them tail to tail. So if we look in this situation, we have R1 placed tail to tail with R2. So if we want the change in R, we draw an arrow from the head of the first one to the head of the second one. And if we look here, this is another way of representing the change in the position vector by placing them tail to tail. It's just another way of doing it to find the displacement. It makes sense though, because where do we start? We started at R1 and then we moved over to R2. Well, how much did it change? Well, we went from there to there. It makes sense that that's the actual change in the position vector itself. So here's another way of looking at it. Subtraction of vectors is tail to tail, not head to tail.